Hello guys, today we are going to dive into the concept of steam. Well, what is steam? Well, a pure substance can exist in three phases, namely the solid phase, the liquid phase and gaseous phase. So, water which is existing in gaseous phase is known as vapor or steam. Next, what is saturation temperature? Well, the temperature at which liquid begins to boil and starts to convert into vapor is known as its saturation temperature. This temperature depends on various pressure conditions. Next, moving on to the types of steam. First, we have wet steam. Well, wet steam is a mixture which contains both saturated liquid and vapor which is formed at a saturation temperature for a given pressure. Here, the water particles have not yet absorbed the latent heat and hence result in a two-phase mixture. Next, we move on to dry saturated steam. Well, it is a type of steam which does not contain any particles of water. It exists completely in its pure vapor form for the saturation temperature at a given pressure. Next, superheated steam. Well, it is a steam which is heated to a temperature which is much higher than its saturation temperature is called as superheated steam. The temperature at which superheated steam starts to form is known as superheated temperature. The advantages of superheated steam is that it will contain a large amount of heat energy and hence the capacity to do work and its thermal efficiency will be very high. Next, moving on to steam properties. First, sensible heat. Well, it is the amount of heat energy required to convert 1 kg of ice into water at a given pressure. Here, water in solid phase is converted into liquid phase. Next, we move on to latent heat of evaporation. Well, this is the amount of heat energy required to convert 1 kg of water in liquid phase to that of vapor phase at a given pressure. Here, the vapor will be dry saturated. Next, superheat. Well, it is the amount of energy of heat required to increase the temperature of dry saturated vapor into superheated vapor. This process is known as superheating. Next, we move on to dryness fraction. Well, this is the ratio of the mass of dry steam present in the wet steam to the total mass of the wet steam. As you can see in the formula, mg is the mass of dry steam and mf is the mass of suspended water particles. For example, if there is 1 kg of wet steam which contains 0.9 kg of dry vapor, then its dryness fraction will be 0.9. This dryness fraction will always have a range between 0 to 1. For completely dry steam, the dryness fraction is equal to 1. Next, moving on to enthalpy of steam. Well, it is defined as the amount of heat energy contained in a unit mass of steam. This can also be expressed as the sum of internal energy and the products of pressure and volume of the steam. It is expressed in kilojoules per kg. For dry steam, it is denoted by HF plus HFG. For wet steam, it is denoted by HF plus XHFG, and for superheated steam, it is denoted by Hg plus Cps into Tsup minus Ts, where HF is the sensible heat, HFG is the latent heat, X is the dryness fraction, Hg is the total enthalpy of the dry steam, Tsup is the superheat temperature, Ts is the saturation temperature, and Cps is specific heat of superheated steam. Next, we move on to internal energy. Well, every substance will have a definite amount of heat energy stored in it, and this energy is known as internal energy of the system. This can be expressed as enthalpy of the steam minus the external work which is done for evaporation. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.